end behavior. Graphs behave certain ways for extreme values of x, right? Meaning as you get further and further away from the y-axis in terms of x. So, you know, we typically go with the negative 10 to 10 interval. So here it's negative 5 to 5, but what if I were to go out to 100 or 1,000 or 10,000? You know, what would be the behavior of the graph? Having a sense of how that graph behaves tells us a lot about the function, right? So, end behavior is basically that. That's what this verbiage is telling us. So as x approaches, whenever you see the sideways arrow, it's talking about approaching. Unless you're in a geometry class, in which case it'll mean if then, but here it means approaching. All right, is approaching. So this is telling us, basically in terms of this graph, as x is approaching positive infinity, so if I were to continue going out to the right forever, where would the y values, because again, f of x is really just talking about the y values. It's saying the y values are approaching infinity also. So never lose sight of the fact, and it's an adjustment. I didn't like it when I was a student either. This f of x nonsense, it's not nonsense. It just seems like it right now. And maybe even for this entire course. Maybe even for the next entire course. But eventually it'll stop being nonsense and it'll become second nature, and you'll understand why you're learning this notation. It'll make all the sense in the world. It just doesn't feel right now. It's like, it seems like we're purposely taking something that you understood why and making it into something less understandable just to make math hard. That's what it seems like right now. I promise you there is a reason why we're doing it. It's not to torture you, all right? So, yeah, it just, unfortunately, you have to take my word for it at this point. If you don't believe me, you don't believe me, but I'm telling you the truth, I promise. So, as x goes out to positive infinity, I think we all agree the graph's going up. It's got an arrow, which means it's never going to stop going up. So in terms of y values, there's no reason to think it's not going to go to infinity, right? If this pathway, if this number line goes up to positive infinity, then so will the graph itself, all right? As x goes out to negative infinity, it's weird because the arrow is pointing to the right, but it's implied that on your graph you're going to the left because it says negative infinity there. Negative infinity is this way. All right? It's like when you go into a train station and you're like, all right, I'm buying a ticket to go to Grand Central Station. And you go up to the tracks. It doesn't always say necessarily, okay, you're going to track 1, which is that way. It just says, sign, track 1. You just know, okay, well, track 1 is over there. That is the direction I'm going to go. So negative infinity is over here. Regardless of what this arrow says, negative infinity is over here in this direction. So that means I'm following the graph this way. So as I follow the graph in this direction, I'm following the curve itself. I'm going down. I'm going down forever. Down forever is symbolized as a negative infinity. So negative infinity for x in this graph corresponds to a negative infinity for y. All right? So that's the highlighter. I like to do a little table for my end behavior. Gets the job done. Some questions will call for an explanation, but how do you describe the end behavior? I mean, you could write it in words if you want, but really I care about two things. I care about x going to infinity, x going to negative infinity. All right, so if it helps, label up your graph. put infinities wherever it makes sense to put infinities. I got an infinity here, I got a negative infinity there. You know, obviously it's not the next number after like 5 and negative 5, but you know that you're going in that direction. So if I were to follow this graph, so I'm following the curve, and I'm going out in the direction, in the right-hand direction, towards positive infinity, following the graph, where am I going in terms of y?
Negative infinity.
Negative infinity. As I go to the left forever, where am I going? Positive infinity. All right, so we're going to use this graph to answer these questions, which is obvious. What interval or intervals is the function positive? Okay, so positive means that the graph is above the x-axis. All right, so these questions are putting together everything from the lesson. So it's not just looking for increasing or decreasing, not just looking for turning points, it's looking for everything. All right, so above x-axis. All right, and feel free to mark up the diagram. So just, you know, zoom in on your sheet. And then mark up the relevant pieces. Well, it wouldn't be positive on the x-axis, so I'll just draw a line right on top of that x-axis, and I'm going to call that 0. And then I'll highlight everything else in red that's above the x-axis. All right, so what I want to do is state the x values for which this graph is above the x-axis. So the x values corresponding to the parts that I highlighted in red. All right, so it looks like I'm starting here at, I mean, I got to take a stab at it. It looks like it's negative 2.5. All right, so I could write negative 2.5. I think everything else, well, actually, and then it stops here at, I'm guessing that's 1/2, or I'll write it as 0.5 because I wrote the other one as a decimal. Not that it matters. All right, everything else I think is pretty clearly defined in terms of a value, and not fractional. All right, so where does my red line here start? I mean, it pretty much just said it, so all you have to do is repeat what I said. Negative 2.5. And where does it stop for that first part? Negative 1. All right, let's talk about fencing here. So bracket or parenthesis for the negative 2.5? Parenthesis, because we can't actually get to the negative 2.5. If we do, we're on the x-axis. If we're on the x-axis, it's not above the x-axis, so it can't be positive. All right, what about the negative 1? Can we get to the x value of negative 1?
Yes.
Yeah, because if we do, we're at that point that's above the x-axis, so we're good to go. So bracket that up. All right, the next interval starts where? Well, that's where it ends, right? Negative 1 with an open circle, so parenthesis. I know it's parenthesis, but it sounds stupid, so I'm not saying that. So negative 1, and then we end at 0.5. Bracket or parenthesis? And unite the sets, because the two sets combined give us the entire set of intervals. Right? So from negative 2.5 to negative 1, negative 1 to 0.5, the only one that's actually included in the set is the negative 1.
Can't we do negative 2.5 and half?
Straight from one to the other? Yeah, because if you're excluding this one, that's fine, but you're including this one, so it covers the gap. You can go that way too. It really doesn't make a difference because all we're stating is the x value. Typically, there's no typical. Like, on a multiple choice question, you can go either way with it. Like on a Regents exam, they might make this the choice, they might make yours the choice. So as long as you can go back and forth between the two, you're fine. All right. Now, increasing. Increasing is different than positive. Increasing means that you could use the word positive to describe increasing. It's talking about a positive slope. All right, positive slope. But in practical terms, it means that you're going uphill from left to right. Uphill from left to right. So as you're reading the graph, you're just looking for the part that's going uphill as you read it from left to right. All right. Over what interval does that happen? So first x value, last x value. -4 and -1. All right. Solid point at -4, solid point at -1. And there we go. All right. Now it says name any points of extrema. All right. So our possibilities. And I think this is the trickiest part because everything else is, at a minimum, it's studying. Right? It's like, okay, what does it mean to be increasing? I'll just memorize what it means to be increasing, and then I'll evaluate the graph. But extrema, it could take on a few different forms. You have, actually 4 different forms. You could have absolute maximum.
That's not what I said. That's not mine.
It says function constant.
Interesting. Okay, so that part C would be none because it never flatlines. So you can make a note of that. But we still need to talk about this, so I'm going to talk about it anyway. All right. We have absolute max, absolute min, maximum, minimum. We have relative max. These are our possibilities. And relative min. Poor quality T there. All right. The absolute maximum is your highest overall. Absolute min is your lowest overall. Now, the relative max and relative min, that's different because all you have to be is higher than the points to your left and to your right. So higher than the points that surround it. Higher than, I'll write surrounding points. Which would make relative min lower than the surrounding points. All right. Unless it's stated otherwise, points refers to coordinates. So x comma y. All right. Sometimes it'll say name any x values that correspond to extrema. All right. That's a different story. All right. But here it's saying name any points. Points means coordinates. So what is the coordinate? Looking at the entire graph, what are the coordinates of the highest point overall? -1, 3. Perfecto. Lowest point overall? -4, -3. Now, is there a point that is higher than the surrounding points? And that means the points that are directly to that point's left and directly to that point's right, which means there has to be points to the right of it along the curve or the line. All right. So maybe you say this point. but there are no points along this path. There are no points to the right, so it can't be a relative maximum. It is higher than the points to its left, but not to its right. This point is higher, if there were a point there anyway, would be higher than the points to the right, but there are no points to the left, so it could not be a relative max. So this graph actually has no relative maximum points, also no relative minimum points. So what we would say is none. We could do one of these jammies, which is a no solution symbol. I mean, you're welcome to write none, but as we know from this unit, you want to start getting in the habit of writing notation. You have to have points to the left or to the right, and to the right of the point that you think is a relative extremum. So something like this would be a relative max because it's higher than the points to the left and also to the right. But if I have a point or a graph like this, just a linear function, I can't call this a relative max because even though it's higher than the points to its right, what points are there to the left? There are none. It has to have points on either side of it in order to be a relative extremum. It can be absolute. It could be the tallest point on the graph. It can't be relative because it has to have points on either side, which means it has to be part of a path, never an endpoint. All right. Good question. Are these questions consistent with what you have on your paper? It's constant.
No.
The last one's constant for each one, or what? What are we looking at? Oh, just no, relative max, and then end behavior for that. So it's the first one that should be constant, but everything else is the same?
Yeah.
Okay. So I'll just remember to talk about that in a sec. That's weird, because what I have on my screen is actually a better version, because both of these graphs, they don't have any instances in which the graph is constant and never flat lines. All right, anyway, interval for which the function is negative. All right, which means below the x-axis. All right, this is a little iffy. That would be this interval. All right. So it doesn't look like it's going directly through 4. I mean, nowhere near directly through 4. Not 3.5 either. I mean, if you had to take a stab at it, what would you say?
375.
375 probably. So the interval for which it's negative would be going from 2 to 3.75. This would be most likely a multiple choice question, and you wouldn't have a choice where it's 2 comma 3.75 and then 2 comma 3.76. You know, it's not going to be like that. It would be like 2 comma 3.75 and then negative 2 comma 3.75.
Why is it 2? How?
2?
Oh,
Or is it 2? Not including, right? Because if it included, it would be on the x-axis, and on the x-axis it's not negative, it's equal to 0. Decreasing would be where it goes downhill. So we're talking about from here to here. We'll start with that one, which is what interval? Starting?
5. Negative 5, negative 2.
All right, both solid points. What's the next interval?
0,
0 to 3. So that would be this part of it. And then we'll unite those two sets. There is a gap between them, so it's not like like the other one where we could just write it in one stretch. If we did, we'd be including a part that doesn't make sense, so this is how it has to be. The end behavior. Well, they're solid endpoints. So the end behavior, when we were talking about it on the previous page, We were talking about whether it goes to infinity or negative infinity. Well, that only happens if it has arrows. Here, as x approaches negative 5, y approaches 3. So it's actually approaching particular numbers instead of infinities. As x approaches positive 5, y approaches 5. All right. And the question on your page says, on what intervals is the function constant? It's never constant because it would have to go horizontal, a horizontal line segment in order to be constant. That's not the case anywhere. So never constant. But the end behavior would be like this. All right. All right, positive. Anything above the x-axis, what am I looking at?
Negative to negative infinity, or negative infinity.
Negative infinity comes first, then going to negative 2. And then 2 to infinity. All right, those arrows are telling us that we're dealing with something infinite. Since our x values start at negative infinity and go to positive infinity, that's what we're looking at. Something to keep in mind, and it's very important, and I've mentioned this a few times, but I don't think I can mention it enough. We're only talking about x values here. All right, when we're talking about intervals, only talking about x values. So tell me the x values for which the particular region, in this case the positive region, starts, and the x values for which it stops. You're not talking about the y values. So you see this, it's going up, you might say infinity, but that would be addressing the y values. I want to know the x values for which it's a positive function. All right. What interval or intervals is the function negative? All right, so that would be below the x-axis. Negative 2. Well, it's the whole shibiggity bang here, right? But not including the 0? Oh, is that what you're saying? Okay. It's neither, okay. So then, not including the 0, and then the rest of the way, 0 to 2?
Yeah.
Good, good. Right. So again, we can't include anything on this x-axis because that's going to be 0. All right. So negative 2, go into the 0, not including the 0, and sometimes, you know, just you mark up the graph any way you want. I'm not looking at your graph when I'm grading the paper. So if you want, just kind of save yourself. Make little open circles on the x-axis so that you can remind yourself that you're excluding those points when you're stating the domain of the particular interval. Name a relative maximum. Okay, well, turns out there's only one anyway, so where would that be? 0, 0. All right, that is definitely a point that is higher than the points to its left and also the points to its right. All right, and you could draw any kind of curve you can think of, and with that curve you can identify whether there's a max or a min, or a relative max or a min. So if you wanted to do something like this, you know, you have this ever so slight drop from this point here, so you'd have a relative max here, and then a tiny little dip, and then a relative min here. It doesn't have to be very much bigger than the points that immediately surround it. It just has to be bigger. It could be a teensy tiny bit bigger. Could be a lot bigger. It all depends. Positive interval. This one's nice.
-4.
Parentheses on both. Parentheses on the -4 because we don't want to be on the x-axis. parentheses on the infinity because,
It doesn't get practice.
yeah, infinity always gets parentheses. Now the end behavior, again, that's all we're doing here is talking about where x is going and correspondingly, if that's the word, where y is going. All right, if x is going to, and a piece of advice, mark up your graph with infinities. Negatives to the left and bottom, positives to the right and top. As x goes to negative infinity, so it's going to the left. If you were to trace the graph to the left forever, where are you going in terms of y? Up or down? Negative infinity, down. If I go to the right forever, where am I going? Infinity, I'm going up.